I'd like to review one of the most important theorems in all of mathematics, and a theorem that we'll use a lot in this trig course. This theorem is known as the Pythagorean theorem. Most of you have probably seen it before, but we'll review it again real quick. It says, if we have a triangle, ABC, and it is a right triangle, okay? So we have a right triangle with sides A, B, and C, where C is the hypotenuse. Remember, the hypotenuse is always the longest side. It's always opposite the right angle. Then, if we have this right triangle, then the following must be true. A squared plus B squared must equal C squared. Okay? So there's the Pythagorean theorem. Let's take a look at a couple examples that I have drawn up for you. Here are two right triangles. And what we have to figure out is what are the lengths of the missing sides. Okay, so we'll call this A, we'll call this B. Remember, the hypotenuse is always C. So in this case, we want to solve for C. Well, we know that A squared plus B squared is equal to C squared. So I'll just plug in my values. We said A was 8, so 8 squared plus 6 squared must equal C squared. 8 squared is 64. 6 squared is 36. 64 and 36 is 100. So C squared must equal 100. Remember, to solve for C, we can take square roots. So C is equal to plus or minus the square root of 100. Well, since we can't have a negative length, the positive square root of 100 is just 10. Okay? So by the Pythagorean theorem, we found that longest side is 10. Now look at the difference between this problem and this problem that we just had. This problem, we're given C. We need to find either A or B. It doesn't matter which one we call A or B. I'll just call that missing side A. And again, we know that A squared plus B squared equals C squared, and I'll just plug in all our values. A, we don't know. B, we know is 5, so I'll go 5 squared equals 13 squared, and we'll try to solve for A. A squared plus 25, that's the square of 5. 13 squared is 169. If I subtract 25 from both sides, let's see, 169 minus 25 is 144. Again, taking square roots, I get A equals plus or minus 12, but since we're talking about a length which is positive, I must take the positive value. So A is 12. All right. Let's define one last thing. Here's a definition. Throughout this course, when you view these lectures, I will usually write definition first to indicate that there's a definition coming up. Okay? Definition. A triple of numbers is called a Pythagorean triple. This should say if. So a triple of numbers, A, B, C, is called a Pythagorean triple if it satisfies the Pythagorean theorem. For example, 6, 8, 10 is a Pythagorean triple because it satisfies the Pythagorean theorem. 5, 12, 13 is also a Pythagorean triple. Okay? In our example here, we want to show that this number, square root of 2, 4, 3 root 2, is a Pythagorean triple or is not a Pythagorean triple. So all we have to say is this is A, the 4 is B, and the last number is C, and we'll see if it satisfies the Pythagorean theorem. So let's check it out. So we want to figure out, is A squared plus B squared equal, maybe we'll put a question mark, to C squared. If it's true, then it is a Pythagorean triple. If it's not true, then it's not. Well, the square root of 2 squared, if we square a square root, they just simply cancel and we're left with 2. 4 squared is 16. Now to square a number like this, we square the 3, which is 9. We square the square root of 2. Again, the roots are just going to cancel. The root will cancel with the square. And 2 plus 16 is 18, and 18 does, in fact, equal 18. Therefore, the number square root of 2, 4, 3 root 2 is a Pythagorean triple. So pretty much a review lesson, but you might want to try some of the homework problems and refresh your memory.